Hi, everybody. Thanks for coming. Today, we're going to teach you how to master the AWS SDK for PHP. My name is Michael Dowling.
I'm Jeremy Lindblom, and we're on the engineering team at AWS that produces the AWS SDK for PHP.
So in order to transform you into master of the SDK, we're going to teach you about some of the low-level concepts, and we're going to go all the way up to some high-level concepts that can speed up common development cases. So, do what? Oh, yeah. There we go. Now you can see it. OK, great. In the first part of this talk, we're going to talk about low-level concepts. We're going to show you how to install the SDK. And we'll show you how to send web service operations. And in order to illustrate these points, we're going to walk you through a pretty basic use case of creating an Amazon S3 bucket, uploading an object to that bucket, and then listing the contents of that bucket. Now, in the second part of this talk, we'll cover some of the high-level features. And these help to speed up common development tasks. And it includes things like our Amazon S3 Stream Wrapper and how to upload an entire directory of files in parallel to host things like a static blog or a static website. So before we dive in, I'll introduce the SDK. It's an open source project that you can find at github.com/AWS/SDK-PHP. You can send pull requests, you can see open issues, and we're pretty attentive to that. And so the SDK is a HTTP client, and it helps you to interact with our various web services in a pretty consistent and easy-to-use way. It takes care of all kinds of low-level stuff for you so that you don't have to worry about it. For example, serializing requests, automatically retrying failed requests with exponential backoff. And it also handles mapping all of our 30-plus APIs into a really consistent way. So we take care of worrying about these low-level things for you so that you can just worry about building your applications, and we kind of get everything else out of your way. So it's a suite of HTTP clients. It's built on top of a library called Guzzle, which you'll hear a little bit about in this talk. And Guzzle's an HTTP client for PHP that I actually created a few years ago. And it provides the SDK, its foundation. It's a framework that we built it on top of. And it gives us access to a lot of really powerful features that Guzzle provides, like persistent HTTP connections, which allows you to utilize the same open socket over and over. And it also provides the ability to send requests in parallel. So you can send 50 requests in parallel, and you're only as slow as your slowest request at that point. And in addition to all these great features that we get from leveraging Guzzle, Guzzle also gives us a event-driven hook system. So you can plug into certain lifecycle events of a request and add in custom business logic that you might need for your application. And also, the SDK exposes various high-level functionality that you can use. And we'll cover a lot of the high-level features of the SDK throughout the talk. And next up, now that you know how to install what the SDK is and some of the basic concepts, you need to install the SDK. And this can actually be done in several different ways. And the way that you choose is going to really be dependent on your application, how you deploy your application, and just your requirements. So we understand that PHP applications are deployed in a myriad of different ways. So we offer a Composer and Packages repository. And Composer is a dependency management system for PHP. And it's almost become the de facto standard for new PHP projects. And it's a really great way to declaratively specify your dependencies and to allow Composer to handle auto-loading and determining a dependency closure for you. In addition to Composer, which is definitely our recommended manner of installing the SDK, we also offer a FAR file, which is similar to Java's jar files. It's every file that you need to run the SDK, all combined into a single file, and includes an autoloader. There's also a zip, which includes all the dependencies if you want to just unzip that onto your server or FTP it up. And if you're still using pair, then we have a pair channel. And finally, we have Amazon Linux provides a Yum repository that you can just Yum install the SDK. And installing the SDK with Composer is really, really easy. All you do is, first you've got to go to getcomposer.org, and they have installation instructions for whatever system you're running on. And once you've installed Composer's FAR file, that single file, then you just create what's called a composer.json file in the main root of your project. And this composer.json file, it's just a list of your dependencies. And Composer scans this and sees, oh, hey, I want the AWS SDK for PHP fuzzy version 2.4. And what that means is that you're going to get every version of the SDK from 2.4 all the way up to, but not including 2.5. So that helps you, it helps stop you from bringing in a new version of the project that may have a breaking change or something unexpected you didn't think would happen. Once you've done this, you just run composer.far install. And Composer goes out, figures out all the dependencies that you have in your project, and then all of those dependencies, and then ends up downloading all of them and creating an autoload file. And this allows you to just, you include Composer's autoload file, and automatically you just call new class, and it figures out where that goes.
All right, so you're here to become masters of the SDK, so your apprenticeship officially begins right now. Michael showed you how to install the SDK and identified some of its features, but we're going to walk through the use of some of S3's operations in order to see how the features of the SDK are actually used to do web service requests. So we're going to look specifically at the create bucket operation, put object, and list objects in the Amazon S3 API. And as we look at those, we'll see how the features of the SDK allow you to work most effectively with those operations in a way that you can also apply those same techniques to other services and operations in the SDK. So how many of you here have worked with the Amazon S3 API before? I'm expecting probably quite a few hands here. OK, so that's good. That's about what I expected. I did want to give a brief introduction of S3, just so you're familiar with the terms and we're talking the same language. Amazon Simple Storage Service, or Amazon S3 for short, is our web service that is a scalable storage in the cloud. In S3, you work mainly with two types of things. You have buckets and objects. So a bucket is essentially a namespace or a container for objects, and objects are the things that you store in S3. So a bucket actually has a globally unique name, whereas an object has a unique key within a bucket. So you take the bucket name, the object key, combine it with the S3 endpoint to create a unique URL representing your object. And you can see an example of that on the slides right now with the bucket name and the object key highlighted. S3 actually has a flat storage structure, and it's more like a hash table than a file system. However, you can simulate a file system by putting slashes in your object key, as I have in this example, and we kind of just pretend like it's directories. And most of the visual user interfaces that you see on top of S3 will display S3 buckets and objects in that kind of way. So, like I said, we're going to look at create bucket, put object, and list objects in the S3 API. So we'll look at create bucket first. What you see on the screen right now is a complete code sample, start to finish, of bootstrapping the SDK, instantiating the S3 client, executing the create bucket operation, and doing a little bit of error handling. Don't focus too much on it, though, because I'm actually going to break this down over the next few slides and look at each part individually. One thing I did want to point out, though, is the first line, which has the require vendor/autoload.php. And that is actually the autoloader that is generated by Composer, which Michael was just talking about a few minutes ago. So like Michael said, using Composer is the preferred way to use the SDK. If you're using a different way to install the SDK, you'll use a different type of require statement. But no matter what installation method you use, our user guide outlines each way to bootstrap the SDK and what you need to use in your require statement. So definitely check out our user guide, which is linked to from the SDK's webpage and our GitHub repository. And there's instructions on how to bootstrap the SDK. Now there's actually two ways to instantiate the client object. So in this case, we're going to create a S3 client object to use the S3 service. There's the client factory method and another thing that we call the service builder. I'm going to show you an example of using both of these methods. If you're using the client factory, you'll basically reference the S3 client object directly, call its factory method, and then pass in an array of options. Now, that array should contain things like your AWS credentials, including your access key and secret key, as well as a region. Now, you notice I actually have the region commented out on this example. That's because you don't actually need to specify a region with S3. It's kind of a special case, because S3 has a default global type endpoint. But you can specify a region if you want to put your buckets and objects in a particular region. With other services like EC2, RDS, Glacier, specifying the region is required. So when you're using a different service other than S3, you should keep that in mind as you use the SDK. There's also something called the service builder that you can use to instantiate a client. And in that case, you'll reference the AWS class and use its factory method. You can pass in an array of options, like with the client factories, but you can also use a config file. So if you specify a path to a config file, the service builder will load that, and any client you create with the service builder will have those configuration settings applied to it. So that config file, well, again, it'll contain things like your credentials, your regions. There's some other cool stuff you can do with it, and the format and all the features related to that are documented in our user guide as well. So once you have the service builder object, you'll use the get method like you see on the screen. We have AWS get S3, or whatever the name of the service you're getting. That will return you the client object with the configuration settings applied. One of the very cool things about the service builder is that if you do that same thing again, AWS get S3, it will return exactly the same instance as the first time you did it. So that's good because you can reuse the same client instance in various places of your code if you have a handle on the service builder object. And the reason that that's a good idea is because if you reuse the same client object, it also reuses the same connection to the service. So if you're making multiple requests to the same service, you're going to want to reuse that same client object because that will help reduce the latency of doing all the requests overall. There's also several ways to provide your credentials to the SDK. You just saw two of them. You can pass them in as an array of options. You can use the configuration file with the service builder. The SDK also supports two other ways. You can provide the credentials as environment variables. So if you have some kind of a configuration management deployment system where you can inject variables onto your server, you can put your credentials on right there. The SDK will actually pick those up automatically. You don't have to tell it to use environment credentials. It'll just look there. Oops. It'll just look there and pick them up and use them. Same thing with IAM instance profile credentials. If you're running on EC2, you can use instance profile credentials, and the SDK will automatically use those. I don't have time to go too much into instance profile credentials, so if you're not sure what those are and you want to talk about it later, please come and talk to me. I'll be glad to explain it. There is an article on our new PHP development blog. The title, Providing Credentials to the AWS SDK for PHP. Michael actually wrote that article. It's on our blog. It explains all four of these ways to provide credentials in detail. And if I handed out some cards with the blog URL on it, if you didn't get one beforehand, I have more up here, so come see me afterwards, and I'll get you a card with the link to our blog. All right, so now that we have an S3 client object, let's get back to actually doing our create bucket operation. So this is an example of how we can do that. We'll call the create bucket method on the client, and that does the create bucket operation in S3. There's a method on the client for each operation, so a one-to-one correspondence there. When you call the method, you pass in an array of parameters, and if the request happens to fail, it'll throw an exception, and that exception will be specific to the service that you're using. So in this example, you see in our try-catch block, we're catching the S3 exception. So there's an exception for each service that you use. So you're probably wondering, looking at that method and passing in an array of parameters, how the heck do I know what parameters I'm supposed to pass into the method? It's a valid question. For that reason, we publish API documentation that's linked to, again, from our website or from our GitHub repository. It's an invaluable tool as you're programming with the SDK. The API docs outline all the methods of the clients, all the parameters that you can pass in to each operation. And you will need that to work most effectively with the SDK. When you do execute an operation, in this case, I'm doing a list buckets operation with no parameters, you get back a result. And that result is what we call a modeled response object. That object implements PHP's array access interface, so it actually behaves like an array as well, so you can use a square bracket syntax to reference the data in that object. Or you can use some of the methods that we have on there. So if you want just a normal array, you can use like the toArray method that's on there. Then you can print R or var dump or whatever you like to do to debug random variables. You can also just straight up echo it, because we have toString on there too, and it'll dump out a representation of the object as well as the structure of the data that would be found in there. So you can use that if you just want to do some quick debugging. I think the coolest method, though, and the most valuable to me, is the getPath method, which you see on the two methods there on the bottom. So getPath lets you specify a path that goes deep into the response structure. So when you do a list buckets command, you get back basically an array of buckets, which is an array of other arrays that can include things like the name. So you can, if you just want the name of the first bucket that you got returned back, that first getPath command would give you exactly that. If you wanted to get all the names of all the buckets that were returned by the operation, you can use wildcard syntax like you see on the bottom line, where it's buckets star name, and that will allow you to get arrays of data from deep within the response structure. So it's very easy to work with the data that comes back there and to get exactly the data you need out of it without having to traverse blindly through some structure. And if you're wondering what the structure of the response is, again, you can go back to the API docs. Not only do we have the parameters, we also have all the data that is found in the response documented in our API documentation. So you can check that out there. Another tool that we have when you're working with requests is the wire logger, which allows you to easily debug any request. This code sample is the original create bucket code sample I showed you at the beginning, but I added a few lines of code here to add the log plugin. So the log plugin is actually an object provided by the underlying Guzzle library in the SDK. So you can create a log plugin object using the default settings by using that get debug plugin method down on the bottom left, and attach it to the client using the add subscriber method. Once that's done, every request you make with the S3 client will dump out debug data to your console. It looks kind of like this. It'll include the entire request and response, including all the headers, the URL, and the response body. So you can quickly see what the SDK is actually doing with the service, how it's interacting with S3. You can do that to debug, or you can just do it if you're curious and you want to know what it's actually doing. The log plugin is one of many plugins included in the SDK and Guzzle. The plugin architecture of the SDK is the same plugin architecture of Guzzle. And so along with the log plugin, there's other useful plugins, including the backoff plugin, which is used internally by the SDK to implement request retries. And then there's other cool plugins like the mock plugin, which allows you to stub out responses returned by a client. So that's very useful when you're testing with the SDK. In your test, you can actually tell the client object using the mock plugin what you want it to return in your test, so you don't actually have to go and hit the service. So very useful for testing. One other feature that is useful in the SDK is something we call waiters. So going back again back to our original code sample, there was after we did a create bucket operation, there was a method that said wait until bucket exists. So we're going to talk about that. There are many operations with AWS services where when you execute them, the service responds immediately and says, OK, I will do that. But it doesn't mean that it's immediately done. Sometimes you have to wait for it to be created. So a good example is creating an instance through the EC2 API. That usually takes a couple minutes before that instance is actually ready to use. Even though when you execute the request, it comes back right away and says, yep, I'll create it. But if you're working in PHP and you create a resource and you actually want to do something else with that resource in the same script, there's not a good way to know how long you're supposed to wait until you can use that resource. So we built in this concept of waiters in the SDK, where it actually will sleep and pull and check that resource periodically until it's in the state that you want it to be in. So with this example, we're doing create bucket, then we're doing wait until bucket exists, and our script will pause there until the bucket is actually ready to use. So then we can immediately do something like list objects in that bucket or put object right away without having to guess at when it'll be available. All right, so we looked at just the create bucket operation there, but I already showed you a ton of features in the SDK, including how to execute operations, waiters, the log plugin and the other plugins, the responses, the API docs. And that was only looking at one operation. So we're going to look at two more. So we'll do put object next. So the put object API is what you use to upload an object to S3. So when you do that put object API, you specify things like your bucket name, the object key that you want to use, and the body, which can either be just a string of data, or with the PHP SDK, you can use something like a file handle using fopen. The SDK can take that, knows how to work with it, pull that data out of the file, and upload that to S3 for you. And up until now, the syntax that I've showed you for executing these operations has been actually the short form of doing it. It encapsulates a ton of stuff. So that whole one-to-one correspondence of method to operation name is actually the short way to do it. On the bottom of this screen, you actually see that there is a longer way to do it. You're probably wondering, why in the world would I use the longer way if there's a shorter way to do it? Well, that's a good question too. But there are cool things you can do with the underlying command object that's normally abstracted from you. So instead of running a put object operation, here we're doing get command method, telling it that this command is for the put object operation, passing in the same array of parameters like we did with the shorthand version. But it doesn't execute the operation just yet. It'll create a command object that can be executed later, so it's like a lazy execution of the operation. So when you want to execute it, you can run the getResult method on that command, and then it'll perform the operation and give you the result. But that command object also has other methods that you can interact with, such as the getRequest method and getResponse method, which actually give you data directly about the request and the response. So you can just examine or even modify headers of the request before you send it. Do cool things like that. The most awesome thing, though, about using the command objects is that this is how you can execute the commands in parallel. So in this example right here, we're creating two put object commands. We're not executing them yet. We're just creating the command objects. I'm going to upload two files, but we're going to do it at the same time. Instead of doing them one after another, we're going to do them at the same time, which should speed up that script that's doing that by quite a bit, actually. And the way that you do that, you create those command objects, and you can pass them into the client's execute method. You can pass in an array of commands. Doesn't matter how you can pass in as many as you want. And basically, you're only limited by your system that you're on, is how many of those you can do in parallel. So we talked about create bucket. We talked about put object. Last one is list objects, another one we want to look at. So list objects is how you list out the objects in your bucket. You tell it the bucket name. You get back a list of objects. The interesting thing about this API is that S3 says, we're only going to give you back up to 1,000 objects at a time from your bucket. So if you have 5,000 objects in your bucket, you actually have to perform this operation at least 5 times to get all the information about your bucket back. And the way that it does that is when you perform the subsequent requests, you have to pass in a marker that specifies where you left off. So S3 knows to give you the next set of 1,000 instead of the same set of 1,000 that you got the first time. So as you can imagine, programming around that model can be kind of complex because you have to keep track of that marker. You have to make sure that you're executing that request more than once. So in the SDK, we have a concept of a feature called Iterators, which is on the next screen, not the black screen. So we have this iterator function, and the iterator objects that you can get from the SDK allow you to iterate through an entire result set, regardless of the limitations of how many you can get back from a particular API. The iterator will take care of handling those markers or tokens. However the service does pagination, the iterator will take care of that for you under the hood. You don't have to actually know how to do the pagination. So one good thing is that instead of trying to get all the results at once, the iterator will only get as many results as it needs. So it only loads into memory enough to show you what you've told it to tell you about. And the iterator objects are compatible with all of SPL's iterator objects as well. So you can tie it in and decorate the iterators from the SDK with the objects that are from native PHP. So to use the iterator, you will do something like this. So instead of calling the list objects operation, you'll use another method, get list objects iterator. And all the iterators in the SDK are formatted like this: get name of the operation iterator. And that will return you the iterator object. Then you can simply just put that in a for each statement and loop over it, and you get back each of those things one by one to operate on. And it'll make the requests to the service as needed to supply you with the item that you've iterated to. So very cool. In version 1 of the SDK, we don't have this functionality. And I'm showing you an example of what it actually looks like to do this type of thing without iterators. So this is an example using SDK version 1 code to do a scan operation for DynamoDB. You can tell that there's a lot of code there, and you'd have to write that on your own to actually make that happen. Well, our customers do not like doing this, and I'll be honest, I don't like doing that either. So we decided to make it so that you don't have to do that. We don't want you to have to write that code over and over again. We don't want you to make mistakes writing that code and get frustrated. We want to provide that functionality for you. So the iterators feature in the SDK allows you to do this much easier. So this is a code sample of the same exact thing using version 2 of the SDK. As you can see, it's much shorter, much easier to comprehend, very easy to use. Just create the iterator object and for each over it. Very easy. Like I said before, these iterators are compatible with the SPL iterator objects provided by native PHP. So this is our list objects example again, except this time I'm decorating the iterator returned by the SDK with a limit iterator, which is part of the SPL library. And when I for each over that decorated iterator, it does the same exact thing, except we've told it with our limit iterator that we only want 5. So you can work with the SDK iterators alongside with the iterators provided by PHP very easily. All right, so we covered just 3 operations in one service, and we saw how the features in the SDK can help you work with those operations very effectively. So we talked about commands, we talked about parallel commands, we talked about results, we talked about waiters, iterators. I think there was more than that too. There was a lot of stuff there, right? So I just want to congratulate you, because you now have my personal stamp of approval. You know everything that you need to know to use the SDK effectively in your application. But you're not quite masters yet. We have some really cool features that we want to show you to help you even more.
So in this next section, so far you've learned some low-level concepts and a little bit of high-level concepts. And if you've soaked in what Jeremy just taught you, then you should be able to go out and build a pretty sophisticated application with AWS. But there's some high-level use cases that we've seen be pretty common for our customers. And we decided to kind of wrap those up in a way that helps to solve that problem, that complex problem for you in a simple and useful way. So we'll go through a few high-level abstractions and talk about those. And the first one, if you've ever needed to use Amazon S3 like a local file system, let's say that you've built a deployment system that you have a build system that you say, here's a path to a directory where I want to put all my build artifacts. And then all of a sudden, you have a development system that has I want to put my files locally on development, but whenever I move to production, I want all my files to be hosted in Amazon S3. Well, instead of having to update your application to add new features for S3, and you can actually just use the Amazon S3 Stream Wrapper to tell PHP to handle all that interaction for you. So PHP actually has a built-in concept called Stream Wrapper. And what this does, it provides a consistent input-output interface for various file-like protocols. So you can use functions that you're probably already familiar with, like fopen and fread, file get contents, things like that. And these functions, they actually create resources, and then you can read bytes from these objects as needed. And when you pull bytes off of these resources, you don't have to read the entire resource up front, buffer it, and then go back and do your script. Or you don't have to write all your data, buffer it, and then eventually write. So stream wrappers allow you to read data on demand as needed, and they also abstract away the file system into a consistent interface. So you've probably all used a function like this before, where you just say file get contents, and you pass the path to a file. It's really simple. What this is going to do, it's going to open that file and load the body of the file and then return it. But you might not know that this call, file get contents with that path, is exactly equivalent to passing in file : / and then the path. So that means whenever you're using PHP and you're using fopen in these file-like operations, PHP uses what's called a stream wrapper protocol to know this is what I'm using, and there's got to be a stream wrapper registered to handle this protocol. When you don't pass a protocol in, it assumes that it's the file protocol, and the file protocol knows exactly how to open local files and how to scan local directories. And so here, file : / is the protocol. Here's another protocol that you've probably all used for really simple cases of maybe downloading the contents of the body of a HTTP request. So here we're getting the body of Amazon.com, and HTTP is the protocol. PHP sees this is an HTTP protocol, so I've got a stream wrapper registered for HTTP that encapsulates the whole process of sending that request and parsing the response. Now, before you can use the Amazon S3 Stream Wrapper, you got to do a little bit of setup, and this is because built-in stream wrappers in PHP are registered by default. But whenever you have a user-contributed stream wrapper for PHP to utilize, you actually have to register it and say, here's the protocol, and here's the wrapper to use. So it's really simple. You just create a S3 client, like Jeremy showed earlier, and then off of the S3 client, there's a register stream wrapper method. And this is going to register that protocol with this client. So anytime that you use stream operations like below file get contents, S3 : / the bucket name, and then the key, it's going to actually utilize that client object. And so you can do really cool stuff with that by, for example, you could create a client that has the log plugin, which would still show that log output that we talked about earlier, but it would show it for even every stream operation as well. So you can see these operations are really similar to what we just looked at. But here, S3 is the protocol. And then after S3, you're going to always pass in a bucket name. And that bucket name is going to be in every operation. And in most operations, if you're working with objects, you're going to pass in a key. And the key is a flat key space, like we talked about earlier. But so local file systems have nested hierarchies of directories. Amazon S3 just has a flat key space. But you can actually do what's called create a pseudo directory with Amazon S3, because you can actually use what's called a key prefix. So let's say that given the bucket name is foo and the key is bad/bar/bam, this is going to generate a URL that looks as if it's a nested hierarchy of files, but really it's just S3 knows that this is the flat key of baz/bar/bam, and this is what your URL would look like. One of the great things that I mentioned about streams and that you can get with the Amazon S3 Stream Wrapper is that you can read bytes off of a stream on demand, rather than having to read everything up front and buffer it and then read the bytes again. So this is really simple, and you've probably all used fopen before, but you fopen and then you pass in a file mode, and this tells PHP, hey, I'm opening this file resource, and I'm only going to access it in read-only mode. Or maybe you'd only access in write-only mode. And in doing this and giving it an accurate representation of how you're going to utilize that stream, a lot of stream wrappers can actually make optimizations on your behalf to do the most optimal thing. So here we're opening a file in read-only mode, and this is actually an object key stored in Amazon S3. You're reading the bytes off of that object until finally you've got the FEOF, which is the end of file, and then you close the file handle. And it's important to always close stream resources, because stream wrappers then can clean up those open resources that it created on your behalf. Another great thing about stream resources and stream wrappers is that you get access to the stream ecosystem. And this includes a lot of helpful features that you can just utilize in your application, whether you're working with a local file system or Amazon S3. So in this example, it's a little bit more complicated than the last one, but it does a really cool thing. As you download data, so you can actually append a stream filter. And what stream filters do is, as data goes through the stream filter, it can actually modify that data and pass it along. So you can modify data as you write it or modify data as you read it. Now in this example, we're opening a Amazon S3 object that's a zipped up object, so key.zip. And then we're going to open another stream resource that is to a local file, and we're going to open that in write mode. As we're writing to that open file, we're going to actually zlib.inflate the contents. So we're downloading the zip file, inflating the zip as we're reading bytes, and then writing the unzip file to the local file system. So in this example too, you can see stream copy to stream is another part of that stream ecosystem where it makes things a lot easier for you, and there's a lot of built-in functions in PHP. And this is going to do basically what we saw on the last slide, read the entire contents of the stream until you hit the end. And then, like I said before, it's really important to close stream resources, especially when you're using stream filters, because it uses a lot of buffering, and oftentimes those buffers that it utilizes aren't really flushed, or data isn't really transferred until you actually close those resources. So far, we've talked about how to abstract like object operations, reading data, writing data. But stream wrappers also allow you to abstract file system functions of listing directories and listing the files that are inside of a directory. So here's an example. I don't know if y'all have utilized opendir. It's one of PHP's kind of wonky ways to open a directory handle, and then from the directory handle, you can iterate over the contents of the directory with a function called readdir. So this is an example of that. Along the way, you can notice that we have isdir, which if you pass in, say, s3://bucket_name, like the example there, then it would actually do a head request on that bucket in Amazon S3, and it would determine whether or not that bucket exists. And there's other functions like file exists, isFile, isdir, things like that that you can utilize that would return the exact same result that you would expect from a local file system. So this example is a little bit weird with the opendir stuff. So PHP actually offers something much more intuitive, the recursive iterator wrapping a recursive directory iterator. So it's way easier to use. But full disclosure, we did not write this, and we did not name this. This is built into PHP's standard PHP library, which is those iterators that Jeremy was talking about. The great thing about this is once you've got this ridiculous thing set up and you've created your iterator, then you can just simply iterate over that, and that's going to yield you back your SPL file info objects. And these actually encapsulate an object from Amazon S3, and they can tell you really useful stuff like the file name, the directory the file's located in, the size of the file, the mode, interesting things like that. So another interesting thing about SPL iterators is that you can actually wrap them with other iterators. And we actually do this heavily in another example we'll talk about in a little bit. So if you were to run that sample, you'd get an output kind of like this, where you've got file and the name of the file, and then eventually you'd get what you see there highlighted in blue is a directory, and then the name of what we called earlier a pseudo directory. So we're actually emulating the hierarchy of a file system with these pseudo directory key prefixes. And you can use that to kind of emulate exactly what you would get on a local file system. So the stream wrapper, it's a really powerful feature that we offer in the SDK. It allows you to utilize Amazon S3 in a way that you don't actually have to tell your application how to use Amazon S3. It wraps that all up for you. You can read bytes on demand as needed, write bytes as needed, and you get to use familiar methods that you've used in your day-to-day activities already. So in the next section, we'll talk about how to upload a nested hierarchy of files and folders to Amazon S3. So this is really useful if you're hosting a static blog or a static website, and you want to build it locally and then upload that entire structure to Amazon S3 and have those same, the file system layout, key prefixes, all of that translated to you to S3's flat key space. Because with tools like Jekyll and Octopress and Pelican making building static blogging even easier and easier, it's become a really attractive alternative to solutions like WordPress or database-driven blogging platforms. And this is because you don't need a database, you don't need web servers, and you don't need to worry about, are my servers up? Can I sustain a huge burst in traffic? Because a static blog hosted on Amazon S3 behind CloudFront, which is our distributed CDN offering, can take all of this load and distribute it across edge locations around the world. So it makes the deployment process easy, and it makes the management overhead significantly less than managing a blogging platform that utilizes a database. So if you don't need these advanced features that you would get from something like WordPress, then a static blogging platform is a really great, inexpensive way to host a blog on Amazon S3. So let's say you have a really cool blog like this. You've got some CSS files, you've got some awesome images like this hand, and then maybe some JavaScript to fork on GitHub to improve the website. So you've got a local file system. You've got images, and that's got its own folders and its own files underneath. You've got your index.html file. And you want this file system to be uploaded in exactly the same way and mapped in exactly the same way to your Amazon S3 bucket. So you might think that would be pretty complicated and hard to do. And it actually isn't. With the Amazon S3 client, we have a high level of abstraction that takes this and makes it as painless as possible. Basically what it does is you pass in a local directory, the path to a local directory, and then the name of a bucket that you want to upload that directory to. And what it does is it recursively iterates over your local directory. It checks if that file exists in Amazon S3, and if it doesn't exist, it uploads it. Or it checks if that file exists on Amazon S3 and has been modified, or the file size has changed since it was last uploaded. And then once it builds up this queue of files that need to be uploaded, it uploads them in parallel as efficiently as possible. We also will automatically switch to uploading really big files using multi-part uploads with Amazon S3, which is a way to take like a 50 gig file and upload that in chunks in parallel. And that helps with better error recovery, and it makes your data, it allows you to do a rolling checksum as well. So the method signature is really simple. 99% of the time, you're just going to pass in the path to a file and a bucket name. Sometimes, though, you might need to host things under a key prefix, and you might need to pass in some extra options that help you to modify how files are transferred or how they're going to be transformed when they put on the server. So a key prefix is a way to put a collection of objects underneath a certain path. So here we're putting objects under blogs. Let's say you have a website and you want your blog to be under this path, but maybe you want your awesome dating profile to be under like dating or something. So we put blogs under here, and then we're passing the key prefix as a third argument. And then there's several options too. Like you can pass in parameters, and these map one-to-one with the parameters of a put object operation. So we're going to say ACL is public read, which is going to be really important for hosting a blog and want people to be able to read it. And then concurrency is uploading files in parallel. This controls the number of maximum uploads you can do in parallel. If you're uploading really big files, we've seen that if you lower this number to a lower amount, like say 5 to 10, you'll get better throughput. And then if you have really small files, you might want to raise that to a higher number. And finally, there's debug, which will show you exactly what's happening, what's being sent from where to where, and the size of that file. And this is kind of what it would look like. And that's a really great feature. And you can host your blog, you can upload your blog. But after you've uploaded your blog, let's say your laptop caught on fire, you lost it or something, and you need to back up your blog back to your local computer. We actually have the inverse of that function, and it's called the download bucket method. It's got the exact same method signature. You pass the local directory that you want to download to, and you pass the bucket name you're downloading from, and it handles the rest. A really great feature that shows kind of how you can reuse these tools that we offer with the SDK and build up bigger tools that have an easier to use interface is this example here. What we're doing is we're actually going to synchronize two Amazon S3 buckets In order to do that, we're using the Amazon S3 Stream Wrapper. The upload directory method doesn't care if it's a local file system or if it's a remote file system. It's just going to iterate over the objects in that bucket using a directory iterator. So here we're actually syncing the contents of a remote directory to another remote Amazon S3 bucket. And finally, people like to use the AWS SDK for PHP in a way that's idiomatic with the framework of choice for them. So we offer several options, and it's not a complete list of every framework that we have or every framework out there in the PHP community. This is what we have so far. We have Laravel 4 service provider, if anybody uses Laravel. This hooks in the SDK to Laravel in a way that you can utilize their service locator. The Zen Framework 2 module, and a Silex service provider as well that hooks in with the Silex Pimple DI container. These are really active projects, and these are driven a lot by user-contributed data on GitHub, and we really value those contributions. And if you have any feedback or if you'd like to see another framework integration, please come talk to us after the talk, and we'd love to hear your feedback and see if we can get that going and create more modules like these.
Well, I'd like to thank you for being here today. Again, just to sum up what we talked about today, we went through using the SDK, how to install it, how to execute operations, cool features like the iterators, the waiters, parallel commands. Michael showed you some pretty awesome stuff that we have built over the top of S3, including the Stream Wrapper, so you can simulate a file system very easily, work with S3 as a file system, and then the upload directory and download bucket features so that you can sync up and down to S3. So lots of cool stuff. I hope it helps you to work with AWS more effectively. And with that, I think we can consider you masters of the SDK. You know all the secrets, right? Cool. Pat yourselves on the back for that. That's pretty awesome. Good job. Thanks for being here. Just wanted to bring your attention to some of the things that we have, some of the resources for you. We have our GitHub repository where you can see our source code. You can contribute to our source code. We love people who want to help out. If you run into any issues, you can report them there. We got some homework for you. We want you to definitely go star our repo so you can stay up to date with the releases. We want you to go try Composer install, download the SDK in your project, check it out. We also have our blog that we released, I think it's been about 3 months now, so it's still fairly new, but we publish pretty regularly. We publish articles about how to use the SDK, how to do certain things, what events we've gone to. We'll have a summary of our information here, including links to our slides and video once those are ready. So if you didn't get a card here with the link to the blog, please make sure to come get one so you don't forget how to get there. But we really just want you to use PHP, go build cool stuff in the AWS cloud. That's why we're here, is to learn more about AWS. So definitely appreciate you being here with us today. So thank you very much.
We'll take questions.